Thank you very much. So yes, as has been mentioned, we're very excited about this new grant that we received from the US EPA, a very large grant for US EPA, $4.8 million, which is probably one of the last large grants that they may be giving out for a long time. Anyway, we are very interested in looking at all these different novel materials that are coming out on these different applications that we've been talking about and we see out there, and trying to understand how could we provide some early evaluation about the life cycle impacts and implications of these materials. So as we begin to work with people like Brian or with Steve, can we provide early on some information that would help to understand what could be those and how does that guide your design and product and material selection? So that's the objective here, to try to be able to provide that early evaluation. The group is composed of 6 faculty here. We have Sang-Won Soo, who we've already heard about. He works a lot on life cycle assessment questions. Ram Shashadri with materials and chemistry. Susanna Scott, chemistry and chemical engineering. So she has a lot of background also on the chemistry of these systems. Myself on the fate and transport and life cycle implications. Chemical engineering with Michael Doherty, and then Dave Austin on the energy and materials efficiency, as well as providing administrative directorship for the program. So one of the questions we are facing, one of the issues we're facing is that there's thousands of chemicals coming on board, materials, all sorts of chemicals and novel applications every day. This is actually a few years ago, 2006, was 4,000 added to the registry. Today, it's closer to 10,000, or it's a little bit more than 10,000. Clearly, we're not going to be able to address all of them. So one thing we need to do working with industry is what are the important ones? Which ones are the ones we should focus on? Are there classes that we should be paying attention to in particular? So that's something that I'll bring up at the end. And so what we want to do is create this rapid screening tool that will be eventually an online tool that you can go in there, look for information, run through scenarios and come up with what are the potential environmental impacts with regards to the resource question that we were asking before. Are these materials going to be available? Are there any issues in terms of where they're found and all that? So that type of question. CO2 and many other potential impacts, energy requirements, the energy needed for synthesis, for product use, or for the disposal, for recycling of these materials. What are some of the implications? Water and other resources as well, and toxicity. Are there questions that we need to be addressing? And perhaps those toxicity questions can be minimized by compacting the material, having it less exposed. So maybe that material will never actually see any environmental impacts until its disposal phase. And then if we can manage that disposal phase, there is no major issue with that. We're dividing our research group into these 8 themes, where we're going to be first starting out with early on tool design, brainstorming what should this tool look like, and we're going to have a workshop in the fall where you're going to be invited, as well as other industrial partners, to give us ideas of what would be the most useful tool and what would you like to see from that tool. What are some of the important aspects of the tool that are important, including how do we handle IP, how do we handle confidentiality information, because we want the tool to be eventually fully available. We want to make sure that we provide in the database ways for you to be able to handle those questions. We're also working on data and data exchange formats. How do we handle that information? How do we make it easily transferable across our various model platforms? Then we have a group that is going to do chemical process design, trying to create big picture. What does this process look like? What are the various unit processes that compose this particular manufacturing, the synthesis of this material, so we can get an idea of what are the resource requirements, the energy requirements, the outputs. Myself looking at the fate and transport, I'll give you some examples of that, but basically what are the likely uses of these materials, the releases that we may have, where they go, what are the impacts on different environmental compartments, then combining that with the life cycle impacts assessment, trying to get an idea of over the life of this product, where are those impacts, how big are they, can we minimize them by the way we handle them. All that will be eventually combined into this tool, but we need to have a back-end module that helps us to bring in these various models that will have these predictive models into the front end, the open access tool. So this will be basically the back end work that connects the various independent models to the front of our web page tool. And then we'll have a number of pilot studies where, again, we'll be working with industry to create an idea of what are some interesting case studies that we can use to test the tool to figure out, do we have the right type of predictives? Is it doing a good job in predicting what are our aspects, some of the issues that we have? And we'll also be looking at education and outreach as an additional aspect of that. So we want to have internships with industry, and we want to have interactions, for example, with the Natural History Museum and other institutions. The conceptual diagram is that we need to have external and available data. So some of it will be publicly available data. We'll try to work with as much of that as we can. Information that's already available in terms of resource availability, process information that we have, toxicity information for whatever's already out there, and create, therefore, a default database library for various chemicals and materials that we'll be using, as well as use and end-of-life parameters. And then there'll be a separate section where users can come in and provide their information. Again, the idea is that that will be protected in a way that it's only available to that user if that user decides not to provide it to other users of the tool. Then we'll go into our various modules, the production and the use and end-of-life modules, and create a number of outputs to be able to evaluate the particular scenario. The chemical process module will take information on what are the chemical processes, what's the underlying chemistry that's going to be used for making that material, what are the known inputs that are going to be required in terms of the materials, as well as how much energy and water and other resources may be required for that. And then from that, generate some estimates of how much is the selectivity for the product, for the byproducts, and do we have waste and other pollutants that we need to be considering at the early phase. And again, these will be predictive tools, so there may be a range of uncertainties that we need to capture, and we'll be tracking the uncertainty as we go throughout the whole process. Next comes, we'll have a pilot study for that, looking at the conversion of lignin to liquid fuels in aromatics. So this is work that Susanna Scott and many other researchers are doing under the Center for Sustainable Use of Renewable Feedstocks here at UCSB. And the idea is to take, for example, these lignin materials into a biorefinery, create some platform chemicals that then can be used for many, many different consumer products. So we're going to be running that through our initial case studies to get an idea of how we can make some predictions about these different processes and uses for those materials. Then comes the use phase section. And so here the idea is that we have now our product, our chemical of interest, and we have many different applications, perhaps in pharma, in food additives, cosmetics and personal care products, automotive, many different applications. We would like to be able to make some estimates as to what are the expected releases from these various applications to atmosphere, to water, to wastewater treatment plants, to landfill and other applications, to soils. So what are the likely emissions that we may have? And those may be very significant for some applications where the material is consumed and then the products are released. And in other cases, it may be very little in terms of the overall release because, of course, it's encapsulated into a product. And we've done that already. This is something that is an example of how we can use this information. We did this for a range of nanomaterials where we looked at these different nanoparticles that are used in many different applications: silicon oxide, titanium dioxide, zinc oxide, aluminum oxide, many different, including carbon nanotubes and silver, all of these engineered nanomaterials. And based on market information, what are the current uses of those materials in automotive and catalysts, electronic and optics, and so on. So all these different uses, how do these materials flow through the world economy? This is as of 2010. And then how much of that goes to eventually different disposal mechanisms, wastewater treatment plants, waste incineration facilities, and from there into landfills, soils, air, and water. This begins to give us an idea of what is the likely eventual ending point for these materials. And one thing we would like to incorporate into this is the recycling flows. And so that's something that we're working on. What are the likely recyclabilities? For these engineered nanomaterials, actually, unfortunately, it's very low at this point because they're very dispersed in many of these applications. And so the value of the material at the end is relatively low. And so there hasn't been significant recycling. But it's an important question. And so then from there, we go to what happens as these materials go into the environment. And that's where we come up with the release scenarios and then the fate and transport. How far do they go in the environment? How long do they last there? What are the potential exposure concentrations for humans as well as for other ecological receptors. And again, we've done some work already on that, taking these nanomaterials as a case study, where we looked at, and this is the San Francisco Bay Area, given we scaled down our global down all the way to, from global to countries to states in the United States to, in this case, the San Francisco Bay Area, and even looked at what would be the releases from different wastewater treatment facilities around the San Francisco Bay. This is the largest one, and then many other ones throughout the Bay. And then from our projected releases, what are the concentrations of titanium dioxide that we expect to have if we have continuous release of these materials? So we can begin to make some of these predictions as to what would be the likely concentrations that we would see for these materials, and then compare to observed data to calibrate our models and to be able to make better predictions about what would happen. So right now we're working on the development of that back-end module and the orbital design of the integrated system, the biorefinery. Professor Doherty's lab is looking at the production process design modules and how we go through that. Ourselves, we're working on the use and end-of-life release estimates. And Ramsey Chaudhry's group is looking at LEDs within IEE, as well as the resource supply security measures that are significant for many of the materials used in energy efficiency applications. We have this project management team, and the idea is that we want to have an advisory board represented by industrial partners that will be providing us information and feedback as to where are we going, is this the right direction, should we be looking at different case studies, how much should we look at fuel cells versus other materials, and so on. So we're interested in having that collaboration. And so we will be, again, sending more information about this project. Currently, these are the industrial partners for this particular grant. We'd love to have many more of you and others associated with the project so that we can then begin to create a more robust database and a more robust tool. So I'd like to stop there and ask if there are any questions.